we were looking at, okay, the last instructional time that we met, we were looking at mutually, we call it the addition law or the mutually exclusive event or exclusive events. And what did I mention about mutually exclusive event? There were two important, what I can say that two important formulas that I gave you pertaining to mutually exclusive event. And you can explain that in your own words. So what can you tell me about mutually exclusive events?
Sir,
Yes, Elvis?
I would say that there are two events occurring, but there is definitely no intersection between both.
Okay, good. So these are events that are happening simultaneously, However, they will have nothing that will occur at the same time together. It's like you're drawing, like in the case of the probability combined event, whereby you could have drawn, let's say, a seven of spades. They ask you to draw a spade, then they ask you to draw a seven. But you can draw a seven and a spade, which satisfy both. But in mutually exclusive events, then there's no such thing that occur. So there will be no intersection. So what will be the two rules that govern mutually exclusive events?
The addition rule, sir?
Yes, but remember there were two expressions that I mentioned that you should know that the probability of A intersecting B is equal to 0. That's one of them. And that the probability of A union B is equal to the probability of A plus the probability of B. That's for mutually exclusive events. So those are the rules. We mentioned that the probability of A intersecting B equals 0. Then we have that the probability of A union B is equal to the probability of A plus the probability of B. And remember, we have the extended rule as well. If we have more than two events occurring and they do not have any similar events happening at the same time, then we can extend the rule. So we have the extending rule here for any given number of events that does not or will not happen at the same time. Then we look at examples. We look at some examples, which we're going to be looking at more examples today. And and here, this is a special case that you need to look at when it comes to the complement of a set and the event happening. It says here the probability of A intersecting A complement is 0. Can't happen at the same time. Then the probability of A union A complement is equals to the probability of A plus the probability of A complement. This is the addition rule that we just used. And then they should come up to 1 because that's the summation of probability. Now, the other thing that I want to mention to you, we have what is known as exhaustive event. It's just like when you're going and they say that you have exhausted all your resources or you have exhausted all your money. Meaning then that you have used up every possible thing that you have, and there is nothing more that you can do about it. So in the case of exhaustive event, you need to know that if two events A and B are such that between them they make up the whole of the possibility space, then A and B are said to be exhaustive events. And this is something that you need to know because we're going to be using for calculation. So for exhaustive event, we know that the probability of A union B is equals to 1. This is a very important theorem here, a rule or a law here. The probability of A union B is equals to 1. So I hope that you write that down. So they gave us an example here that the possibility space is the integers from 1 to 10. So which means you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, inclusive. Here are the integer below 7. So the integer below 7 is 1, 2, 3, 4, 5, and 6. And B is the integer above 5, which would be 6, 7, 8, 9, 10. Now, if we were to take the union of these two set A union B, like I have told you before, we just need to list the element once. So we won't be listing 6 two times, only once. And if you notice, if we take the union, we have all the members here. So we have used up all the members, which means then this is an exhaustive event, A union B, because if you notice, there is no element that left over when we put the union together. Are there any questions? Are there any questions? Student, I'm not hearing you. Are there any questions?
No, sir.
No, sir, it's clear, sir.
Okay, we have done these here. Okay. We will be looking at conditional probability as well before we look at this problem. Let me go back and see what problem I can use here. Okay, let's look at number 8. I won't give you this one because I will give you this one for assignment, number 6. Let's look at number 8. We have looked at number 7 already last time. Since you all have the necessary machinery to solve this problem, how would we attempt this problem here? It said for events A and B, it is known that the probability of A is equals to the probability of B. And the probability of A intersecting B is 0.1, and the probability of A union B is equal to 0.7. Find the probability of A complement. So what we would be using here excuse. What we would be using here.
Sir, wouldn't we using the exclusive one, sir?
It said here that the probability of A is equals to the probability of B. And what was the first one before we look at the mutually exclusive event? What was the event that we look at? What was it that we look at?
Rule of the combination of events.
Okay, very good. The probability rule of combined events. So we were looking at the probability rule for combined events here. And let me just copy this to expedite the process. Okay, let me see something here.
Sir, like, how can you differentiate between the combination rule and then the exclusive and the other rules, sir? Like, what makes it different to each other?
Well, one has an intersection, the other one, mutual exclusive doesn't have any intersection. So, and in order for it to have an intersection, you should have an event that can happen at the same time. Like when we look at an other pack of cards, I could ask you to draw a diamond, and I could ask you to draw a queen. But in some cases, there's a queen of diamonds, so you could draw a queen of diamonds, which satisfy both events. So that will be for the combined rule. The other one, no. If you're tossing an ordinary die that have face 1 up to 6, when you toss the die, you can either only get 1, or you can only get 2 or 3, 4. You cannot get a 1 and a 6 at the same time. So those are the ones that is is mutually exclusive. Or if you flip a coin, one coin, you cannot get head tail at the same time. You can either get a head or a tail. Is that clear?
Yes, sir. Thank you.
You're welcome. Okay, we have that the probability of A. So we mentioned that the probability of A is equal to the probability of B. So how would we find the probability of A complement? What's the first thing we need to do?
We have to make it the
In
subject.
order for us to find the, what is it?
We have to make it the subject of the equation.
Yeah, but then we don't have A complement there as yet. So what should we do there? I want to see how many problems I have here. If I've discussed all the problems here already, yeah, don't discuss these. I already discussed these. Yeah. So I'm just making sure. They mentioned that the probability of A is equal to the probability of B. If you want to find the complement of any event, remember there was a special formula I gave you at the end whereby I said that the probability of A complement is equal to 1 minus the probability of A. So which means then you need to find the successful outcome first and subtract it from 1 so that you can find the unsuccessful outcome. Are we clear with that? Are we clear with that? So which means then they mentioned that the probability of A is equal to the probability of B. So if the probability of A is equal to the probability of B, then I can substitute this as PA, but they are equal. They gave you that information that the probability of A is equal to the probability of B. So now the probability of A intersecting B, we have that, which is 0.1. And now this will be twice the probability of A. That PA plus PA is 2PA minus the union, which was also given. Which is 0.7. So we will be having here so this will be then here, let me put this here. So 2PA will be equals to, when we transpose the 0.7, then it can become positive, and then this remains as positive 0.1. Like that. So we're gonna have then that the probability of 2p A is equal to 0.8. So when we divide both sides by 2, then the probability of A will be equals to what? When we divide both sides by 2, then the probability of A
will equal to 0.4, sir.
0.4. Are we finished?
No,
No.
sir.
Because what are we looking for?
The probability of A complement.
Okay, A complement. So we know then that the probability of A complement remember, this will be the symbol I told I'm gonna be using for complement. Here. Okay, that will be equals to 1 minus the probability of A. So this will be A complement. So all I will do here is to copy and paste. Since we knew the probability of A already, then we go here and we say this will be 0.4. So the probability of A complement will be equals to, so what will be the probability of A complement? The answer is already there. What will it be?
0.6, sir.
Okay, 0.6. Any question based on this problem?
Sir, will it always be 1 minus will we always use 1, sir, for us to when we're finding a complement for it?
Well, yes, when you're finding a complement, yes. In most cases, you're gonna be using this relationship.
Okay, sir. Thank you.
Okay, you're welcome. Okay, Carl, let's continue. Are there any questions? Are there any
No, sir.
Okay. A and B okay. A and B are two events such that the probability of A is equal to 8/15. Probability of B is equal to 2/3. And the probability of A intersecting B is equals to 1/5. Are A and B exhaustive events? Now, in order for, if A and B are exhaustive events, then what was one of the rules that I mentioned here? Let me go back and show you. I told you to have wrote that down.
It will equal to 1, sir?
That the probability of A union B is equals to 1. Very good. So how would we attempt this question here?
We're going to add probability of A plus the probability of B, sir?
So we said here, so we need to use the same formula for the combined rule. Then we need to see that if A and B, A union B is equals to 1. And if we get 1, then it is exhausted. If we get another value other than 1, then it will not. So all I will do here to change these two signs here, all I need to do is to do a here, which will be, so this will be the union. So this will be A union B will be equal to A intersecting B. Let's see if you give me problems now. Okay, let me check the other operator here. I think it's gonna be not this either. Not this either. Not this either. I go to operators. Intersection. So this would be this here. Okay. So this would be the format that we will be using. So let me copy this formula back and then do the necessary substitution. So they want us to see if it is so the probability of A is 8/15. So this should have been B. Remember, I changed this formula here. And so this would be the probability. This should have been the probability of B. But I still need to erase this. So the probability of B is 2/3. And probability of A intersecting B is 1/5. So this is 8/50. And then this here is 1/5. Now, when we simplify this, what will we get? What will we get here? Your calculator should be able to add fractions. If not, then you do equivalent fraction. Make all of them 15, LCM 15, so that would have been 10/15. And the other one would have been 3/15. So 8 and 2. So remember that would be 10, so that would be 8 and 10. 18. 18 minus 3 will give me 15/15, which is 1. Student, have you calculated this? I'm asking.
Yes, sir. I got one, sir.
Yeah, but I was waiting for the answer and some people didn't tell me. So I have to do the calculation. So now, if this is an exhaustive event,
Yes, sir.
why?
Because it equals to 1, sir, and the rule that you gave us equals to 1.
Okay, we see that the probability of A union B is equals to 1, which is the entire whole. So A and B are exhaustive events. This one I like to give 2. I will leave this one for you to do. So this will be what? Yeah. I'm looking, those are easy. Question. I want to look at something nice. Okay, I didn't want to have look at this one here. It said that tests are carried out on 3 machines, A, B, and C, to assess the likelihood that each machine will produce a faulty component. The results are summarized in the table. Faulty, not faulty. Machine A, we have 3 that is faulty and 12 that are not faulty. Machine B, 2 faulty and 8 not faulty. Machine C, 5 faulty and 15 not faulty. A component is chosen at random from those tested. Find the probability that the component chosen is from machine A. So what will that be? We just gonna explain because I won't be doing it either.
So for number for A, part 1, so it includes both faulty and not faulty, sir?
Yeah. So what will it be?
15?
15 out of what? If you add up everything there, what value do you get?
45?
45. So it's gonna be 15 out of 45, which is 1/3. Isn't that so?
Yes, sir.
No, it said here is a faulty component from machine C. It's a faulty component. So you go at machine C, it's a faulty component. So that will be 5 out of 45. which will be
1/9.
1/9. It's not faulty or is from machine A. It's not faulty and it's from machine A. This is machine A, not faulty, but is from machine A. Or not faulty or from machine A. So what will that be?
Sir, wouldn't it be like 12 out of 35, meaning like from machine A, 12, and then divided by 35, which means that it's not faulty. A plus B plus C, which would give you 35. Wouldn't it be like that?
Yeah, but then you are using the combined event. Isn't that so?
Yes, sir. So it would be
Sir,
like,
it wouldn't
Okay.
be 38 out of 45.
B how much?
Wouldn't it be 38 out of 45?
38. Why 38?
Because it said it's not faulty. So if we see machine B has 8 that is not faulty, machine C has 15 that is not faulty. Then it says or is from machine A, and it's not specifying if it's faulty or not faulty. So if we add 3 plus 12, it will give us 15. Plus the 15 of machine C, it will give 30. Plus the faulty of machine B, it will give us 38.
But okay, but remember, if we look at it, said is not faulty or is from machine A. Now we have machine A here, we have not faulty. So what we need to do is to use the combined event, whereby we're gonna find the probability is from A, the not fault from A, and then we need to find the probability that it's from machine A, because this is not faulty, and then from machine A, and then we need to find that it's faulty and from machine A, not faulty and from machine A. So we need to use the combined result. So we would have used A for the machine A, and let's say F for the faulty one, F complement for the faulty one. So, or F for faulty. Or in this case, it's not faulty, so that would be F complement. So we would have that F complement union A is equals to the probability of F complement plus the probability of A minus the probability of A complement intersecting A. And then from that, you will get that answer from there. So the probability of not faulty would have been 35. Let me see, 12 and 8, 35 out of 45. Plus, from machine A, that will be 15 out of 45 minus the combination will be 12 minus 12 over 45. You got that?
How 12 minus 12 over 45, sir?
Remember, we are using the or means union. It is faulty, and so we are using the combined rule, the probability of the combined event. So it is not faulty, right? That will be, these are all the ones that is not faulty. So that will be 35 out of 45. Plus, from machine A, 15 out of 45. Minus, it is not faulty, and from machine A, that will be 12 out of 45. Minus that. Are you getting it?
Yes, sir.
Okay. Then it says here that it is known that the component chosen is faulty. Now that's conditional probability that we're going to be looking at. It is known that it is faulty. And the only amount that is faulty here is 35. I mean, here. It is known that it is faulty, right? Which is 3, 5, that is 10. Say it is known that the component chosen is faulty. Find the probability is this for machine B. So it's gonna be 2 over 10, which will be 1/5. Because this is the condition given, said it is known that the component chosen is faulty. It's saying it is faulty. How many faulty do we have? 10 altogether, that with A, B, and C. However, they're asking if it's from machine B. So that will be 2 out of the possible 10 that are faulty. So that will be 1/5. You get that?
Yes, sir.
The one that I be giving you there, I haven't given you work yet, and you will get some work soon. I will be giving you this one to do. I will set it up on the one with Abdul. I love that one with Abdul. Where is it? The one with Abdul. Yeah, I think it's down here. Yep. This one here, number 16. In a large garden, there are 7 fruit trees and 13 other types of trees. 6 of the trees have bird nesting in them, but only 2 of these are fruit trees. Copy and complete the table below to illustrate the information. The owner of the garden has given permission for Abdul to play in the garden, but has instructed him not to climb any fruit tree or trees that have bird nesting in them. Abdul select a tree at random to climb. B, find the probability that Abdul will obey the owner's instruction. Given that Abdul climb a fruit tree, find the probability that the tree has bird nesting in them. Very nice problem here. Are there any questions based on the problem that we have done? Because after that, we need to go into conditional probability, and then we need to go into independent events. Are there any questions? Because the class has practically comes to an end, are there any questions?
No, sir.
Not as yet, sir.
Okay. Well, since there are no questions, thank you for your time and enjoy the rest of the day.
Thank you,
Okay,
sir.
sir.
Same to you.
Okay. Same to you all. I'll be logging out shortly. But my computer my laptop seems like it wants to charge. So let me charge it a bit.
Bye, sir.
Okay, bye everyone.